Part C is asking, the widest part of the vase has diameter 12 and is just over 3 centimeter from the base. Using this information and making your reasoning clear, suggest which model is more appropriate. Okay, I already know model A is 4 meters from the base and diameter is 12. So that's close. And then model B is about 3.38, I think. So 3.38 from the base. So you can do 8 minus 8 over root 3, which should have given you 3.38. And then the diameter, I didn't do the diameter in the first part when I was explaining, but when you apply the x back into the equation, y is equal to 4 plus 8 over root 3 times 8 over root 3 minus 8, and then plus 8 as well. So that's going to become root 3 plus 8. So when you apply that back into the equation, you should have got 5.97. But depends whether you've applied the minus or plus. We should have applied the minus in here. Then you would have got the correct solution. So if you apply the minus 8 over root 3, you should have had 5.97, which means the diameter is 11.9 centimeter. They're asking which model is more appropriate. Both of them are close to 12, that's fine. But one of them is saying that it's close just over 3. Just over 3 means this one is exact 3.38. So model B distance from the base is closer to 3 than model A. So therefore, model B is more appropriate. And then follow up, they're asking you to find the volume. So to find the volume, I'm going to integrate times it by pi y squared in terms of x. And to do this, I'm going to take the model, square it. So 4 plus x times x minus 8, x plus 8 over 100. I should square this. Times it by pi. I will talk about the limits at the end. First, let's just make this model a feasible model. Okay, so here, to make this nice, I'm going to put 4 plus 1 over 100 times x minus 8, and then times x plus 8, the whole thing squared. And which is going to give me, when I square all of this, like it's slightly harder. So which means I can take 1 over 100 and then squared common, because it was inside the square. So if when I take it out also, I'll have the square. And then inside the bracket, I'll have 400, because I've taken a 1 over 100 out. That's 400 plus x times x squared minus 64. I've just simplified that. So that's going to be pi over 10,000. And then I'm going to have 400 plus x cubed minus 64x. And then square. We haven't squared it. To square this, 400 squared, I can do a plus b plus c squared is going to be a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. So when I square this, 400 squared, 160,000, x to the power of 6 plus 64 squared is going to give me 4,096 plus 800x cubed, and then 400 times 64 times it by 2, which is 51,200x, and then minus 128x to the power of 4. So I've squared that, I've squared that, I've squared that. So square of that, square of that, square of that, which is this is x squared. And then I've doubled this, multiplied, and then multiplied those two and doubled it. And then the last one multiplied and doubled it. That's the integration that I'm supposed to do now. So 160,000 x to the power of 7 over 7, 4,096 x cubed over 3, 800 x to the power of 4 over 4, 51,200 x squared over 2, 128 x to the power of 5 over 5. And times it by pi over 10,000. Now, what limits do I do this question in? They were asking you to do this between minus 8 and then 8. Because you can see that's 8, that's minus 8. So therefore, minus 8 to 8. 8 on the top, minus 8 at the bottom. And then you apply the values and then subtract them. It's slightly longer, but I think that's possibly the feasible way to do. So 160,000 times 8, 8 to the power of 7 over 7 plus 4,096 times 8 cubed over 3, 808 to the power of 4 over 4, is 51,200 times 8 squared over 2, 128 times 8 to the power of 5 over 5. So all of that minus 160,000 minus 8 plus minus 8 to the power of 7 over 7, 4,096 times minus 8 cubed over 3, 800 times minus 8 to the power of 4 over 4, 51,200 times minus 8 squared over 2, 128 times minus 8 to the power of 5 over 5. I've written all the method for you to understand it, but all of that times the pi over 10,000, which should have given you about approximately 905 centimeter cube. Slowly and carefully put it in the calculator, and then it'll give you the answer. The student pours water from full 1 liter jug into the vase and finds there is 100 milliliters left in the jug when the vase is full. Comment on the suitability. So at the moment, we had about 900. But what they did is they poured water from a full 1 liter jug, which is 1,000 milliliters, into the vase and finds there is 100 milliliters left in the jug when the vase is full. So 1,000, but 100 hasn't been poured in, so 900. So it's approximately there or thereabout. So therefore, the model predicts the volume reasonably accurate.